Hello, in this lecture we find out the length of line segment X. In the drawing we have two quarter circles. Those two quarter circles touch each other here at point B. In addition, we know that line segment AB equals to 1 unit in its length, QS equals to SP, and our mission is to find out the length of this line segment BC that is equal to X. To find out the length of the value of X. Okay, so first of all, this is a quarter circle, therefore this angle equals to 90 degrees, and this is also a quarter circle, therefore this angle equals to 90 degrees, and here in this quarter circle, PA must be equal to AB. They are both the radii of this quarter circle, therefore they are equal to each other. But AB equals to 1, therefore PA must be also equal to 1. Likewise, in this quarter circle, BC and QC, both the radii of this quarter circle, therefore they are equal to each other. But BC equals to X, according to what is given as the question, therefore QC must be also equal to X. X is the line segment that we are looking for. In the next step, we will join points P and B together by a straight line. And we will join points Q and B together by a straight line. We'll copy the right triangle PAB in a new page and we'll implement the Pythagoras theorem in this right triangle PAB. Here by PT is the relation for Pythagoras theorem. Carefully, this is the right angle PAB that I copied from the original drawing. In this right angle PAB, according to the Pythagoras theorem, PB squared, that is the square of the hypotenuse, equals to PA squared plus AB squared. So PB squared equals to PA squared. PA is 1, therefore PA squared is 1 squared, that is 1, plus AB squared. AB is also 1, therefore AB squared is 1 squared, that is 1. So in total PB squared equals to 1 plus 1, that is 2. PB squared equals to 2. We take a root out of this equation, and we get that PB equals to the square root of 2. So the hypotenuse PB here equals to the square root of 2 units in its length. I write it in the original drawing. PB equals to the square root of 2 units in its length. So, likewise, I will copy the right triangle QBC in a new page and we will implement the Pythagoras theorem on this right triangle QCB. Again, by PT is the relation for Pythagoras theorem. So this is the right triangle QCB that I copied from the original drawing. According to the Pythagoras law, in this right triangle QB square, the square of the hypotenuse, equals to QC square plus BC square. So QB square equals to QC square. QC is x, therefore QC square is x square plus BC square. BC is also x, therefore BC square is x square. So in total QB square equals to x square plus x square, this is 2x square. So QB square equals to x square. Here we take a root of this equation. QB square equals to 2x square. We'll take a root out of this equation, and we get that QB equals to the square root of 2 times x square. That is to say, QB equals to the square root of 2 times x times the square root of x squared. The square root of x squared is x. So in total, QB equals to the square root of 2 times x. So you can write down here in the original drawing that QB equals to the square root of 2 times x. Those two right triangles are also associated triangles. Why? Because here PA equals to AB, and in this right triangle QC equals to CB. And we have the rule that in front of equal sides in the triangle there are equal angles. So in front of those two equal sides, we have those two angles that are equal to each other. So if this angle is alpha, then the other angle must be also equal to alpha, because those two angles are located in front of those two equal sides, therefore they are equal to each other. So in the right triangle PAB, the sum of the angles must be equal to 180 degrees. So which angles we have in the right triangle PAB? We have this angle alpha plus this is also angle alpha, so alpha plus alpha is 2 alpha plus this angle, this is 90 degrees. In total, they must be equal to 180 degrees. Repeat again. In the right triangle PAB, 2 alpha plus 90 degrees equals to 180 degrees. We subtract 90 degrees from this equation, and we get that 2 alpha equals to 180 degrees minus 90 degrees is 90 degrees. So we divide this equation by 2, and finally we get that alpha equals to 90 degrees over 2, that is 45 degrees. So this is angle alpha that is equal to 45 degrees in size. And this is also angle alpha that is equal to 45 degrees. If you repeat on the same process on the right triangle QCB, we find out those two angles are also equal to each other. Each angle equals to 45 degrees. So this angle equals to 45 degrees, and this angle also equals to 45 degrees in size. In the next step, I present to you rule number 3. We will implement rule number 3 in our drawing. According to rule number 3, the sum of the angles on one side of a straight line is equal to 180 degrees. So in the drawing we have this straight line AB. If we focus on the upper side of this straight line AB at point Q, Here the sum of the angles must be equal to 180 degrees. So which angles we have at the upper side of AB at point Q? We have this angle alpha and the other angle that is beta. So in total, the sum of the angles on the upper side of AB at point Q must be equal to 180 degrees. That is to say, alpha plus beta must be equal to 180 degrees. You can actually implement rule number 3 in our drawing. Why? Because in our drawing, if we focus on the upper side of this straight line AC, at point B, here the sum of the angles must be equal to 180 degrees according to rule number 3. Okay, so I will copy the straight line AB with point B, and you find that we implement rule number 3 in this straight line AC. So this is the straight line AC that I copied from the original drawing. So which angles we have at the upper side of this straight line AC at point B? We have this angle that is equal to 45 degrees, plus this missing angle that we define as x, plus this angle that is equal to 45 degrees. In total, the sum of those three angles must be equal to 180 degrees according to rule number 3. So in this side of the equation we have 45 degrees plus 45 degrees is 90 degrees plus x equals to 180 degrees. We subtract 90 degrees from this equation. Finally, we get that x equals to 180 degrees minus 90 degrees is 90 degrees. So the missing angle here, x equals to 90 degrees in its size. So this is the missing angle that's equal to 90 degrees in its size. So if angle PBQ equals to 90 degrees, it means the triangle PBQ is a right triangle. So I copy the right triangle PBQ in the new page and we will block this right triangle PBQ by circle. Okay. So actually this is the right triangle PBQ that I copied from the original drawing. I copy also this point S. So the new drawing. So I block this right triangle PBQ by this circle. We have the rule that any triangle can be blocked by a circle, especially the right triangle PBQ. So in the drawing we have peripheral angle PBQ. This peripheral angle PBQ equals to 90 degrees in its size, and we have peripheral angle PBQ equals to 90 degrees. And we have rule number 5 that relates to any peripheral angle that is equal to 90 degrees. According to rule number 5, any peripheral angle that is equal to 90 degrees must rest on the diameter of the circle. In the drawing you have this circle. Inside this circle we have peripheral angle MAN. This peripheral angle MAN equals to 90 degrees. And therefore, according to this rule, rule number 5, peripheral angle MAN is subtended on the diameter of the circle. That is to say, MN is the diameter of the circle. Indeed, it is very easy to see that MN is the diameter of the circle. Why? Because chord MN passes through point O, that is the center of the circle. And we have the rule that any chord that passes through the center of the circle must be the diameter of the circle. So in conclusion, we have here peripheral angle MAN, and because it is equal to 90 degrees in its size, it's subtended on the diameter of the circle. MN is the diameter of the circle. We can implement rule number 5 in our drawing, but because in our drawing we have peripheral angle QBP. This peripheral angle QBP equals to 90 degrees, and therefore, according to rule number 5, peripheral angle QBP must be subtended on the diameter of the circle. That is to say, PQ is the diameter of the circle. PQ is the diameter of the circle according to rule number 5. That is from one side, but from the other side, we have here PQ. PQ, we know that PS equals to SQ. It is given as an equation that PS equals to SQ. So if the length of PS is X, then SQ must be also equal to X because they are equal to each other. So what is the length of PQ in total? In total, PQ equals to PS plus SQ. That is to say, PQ equals to PS, that is X, plus XQ, that is also X. So in total, PQ equals to X plus X, that is 2X. So PQ equals to 2X. PQ equals to 2X from one side, but from the other side, we just right now found out that PQ is also, according to rule number 5, PQ is also the diameter of this circle, and if we define the radius of this circle as R, then the diameter PQ must be equal to 2R. Okay, so PQ equals to 2X and PQ equals to 2R. And from those two equations, we will derive that 2R equals to 2X. Here we divide this equation by 2. And finally, we will get that R equals to X. R equals to X. So here, R equals to X. And here also, R equals to X. That is to say, SQ equals to R and PS also equals to R. So in the new drawing, we actually found out that SQ equals to R and PS also equals to R. That is to say, at point S, the two radii touch each other. And therefore, point S must be the center of the circle. Here, point S is the center of the circle. The center of the circle is located in is the point where all the radii touch each other. Okay, so point S is the center of the circle. So, in the next step, we'll join points S and B together by a straight line. Point S is the center of the circle, point B is a point on the circle itself, therefore SB is the radius of this circle that is equal to R. In conclusion, found out that PS equals to SQ equals to SB. All those three line segments are the radii of this circle, therefore they are equal to each other. So, in the original drawing, we join points S and V together by a straight line. Again, SB is the radius of the previous circle that is equal to R. So if I found out that SB equals to SQ equals to SP, all the radii of the previous circle, therefore they are equal to each other. So in the next step, I will copy the big quarter circle, this big quarter circle, to a new page, and then we will extend the quarter circle to a circle. We'll complete this quarter circle to a circle. So actually, this is the quarter circle that I copied from the original drawing. QS equals to SB equals to R. They are both the radii of the curved circle, therefore they are equal to each other. So in the next step, I will complete this quarter circle to a circle. Completed this quarter circle to a circle, and in the next step I will present to you a new rule, and we will implement a new rule in our drawing. The new rule is rule number 14. According to rule number 13, a central angle is twice as large as the peripheral angle subtended on the same arc. So in the drawing we have a circle. Inside this circle we have this peripheral angle ACB. So this peripheral angle ACB equals to theta in its size, and it's subtended on arc AB. Again, peripheral angle ACB is subtended on arc AB. This is arc AB. And we have also center angle AOB. This is center angle AOB. This is subtended on the same arc, RKB. And because of the fact that this center angle is subtended on the same arc as this peripheral angle, the size of the center angle will be twice as large as the size of the peripheral angle that is subtended on the same arc, RKB. That is to say, if the size of the peripheral angle is theta, then the size of the center angle that is subtended on the same arc, RKB, will be equal to 2 theta. We can actually implement rule number 13 in our drawing. Why? Because in our drawing we have peripheral angle BSQ. This peripheral angle BSQ is subtended on RQB. We also have the central angle QCB. This is the central angle QCB. This central angle QCB is subtended on the same arc, RQB. And therefore, the size of the central angle QCB will be twice as large as the size of the peripheral angle BSQ, because they are both subtended on the same arc, RQB. Now we have to find out what is the size of the central angle QCB. What is the size of this angle? In order to find out what is the size of the central angle QCB, I present to you a new rule and we implement the new rule in our drawing. The new rule is rule number 6. According to rule number 6, the sum of the angles around one point will always add up to 360 degrees. So in the drawing we have this point A. According to rule number 6, this rule number 6, the sum of the angles around point A equals to 360 degrees. In order to prove that this rule is true, I drew this straight line that passes for point A. Now we can implement here rule number 3. According to rule number 3, the sum of the angles on one side of a straight line is equal to 280 degrees. Again, the sum of the angles on one side of a straight line is equal to 180 degrees. So if we focus on the upper side of this straight line at point A, the sum of the angles must be equal to 180 degrees according to rule number 3. According to the same rule, if we focus on the lower side of this straight line at point A, the sum of the angles must be also equal to 180 degrees. So in total, the sum of the angles at the upper side at point A plus the sum of the angles in the lower side at point A will be equal to 180 degrees plus 180 degrees, that is 360 degrees. Exactly according to this rule number 6 that says that the sum of the angles around point A equals to 360 degrees. We can actually implement rule number 6 in our drawing. Why? Because in our drawing, if you focus at this point C, according to rule number 6, the sum of the angles around point C must be equal to 360 degrees. So which angles we have around point C? We have this angle, that is a right angle, plus the missing angle. In total, the sum of those two angles must be equal to 360 degrees. Therefore, the missing angle must be equal to 270 degrees. Why? Because 270 degrees plus 90 degrees is 360 degrees. That is the sum of the angles around point C according to rule number 6. So the peripheral angle QCB equals to 270 degrees according to rule number 6. Therefore, the central angle QCB equals to 270 degrees, and therefore the peripheral angle QSB that is subtended on the same arc RQB on the same arc, RQB must be equal to 270 degrees over 2, that is 135 degrees. So we focus on the associated triangle, triangle BSQ. Triangle BSQ is an associated triangle because side BS equals to side SQ. We have the rule that in front of equal sides in the triangle there are equal angles. So those two angles that are located in front of those two equal sides must be equal to each other. So if we define this angle as alpha, then the other angle must be also equal to alpha because those two angles are equal to each other. And we also know that the sum of the angles in any triangle is equal to 180 degrees. So which angles we have inside triangle, the associated triangle, triangle QSB? We have, this is angle alpha, plus alpha is 2 alpha, so 2 alpha plus 135 degrees. In total, the sum of those three angles must be equal to 180 degrees. We subtract 135 degrees from this equation, and we get that 2 alpha equals to 180 degrees minus 135 degrees is 45 degrees. We divide this equation by 2, and we get that alpha equals to 45 over 2 degrees. So this angle alpha equals to 45 over 2 degrees. It's actually angle QSB. This is also angle alpha that is equal to 45 over 2 degrees. In the next step, we copy the right triangle, triangle PBQ in the new page, and we analyze this right triangle, triangle PBQ. Side PB equals to the square root of 2 units. Side BQ equals to the square root of 2 times x units in its length. And this angle is actually angle SQB equals to 45 over 2 degrees in its size. So this angle equals to 45 over 2 degrees. So this is the right triangle, triangle PBQ. In this right triangle, triangle PBQ, tangents 45 over 2 degrees equals to PB over BQ. PB is square root of 2, BQ is square root of 2 times x. So we have square root of 2 in the numerator and square root of 2 in the denominator, so square root of 2 will get cancelled, and we're left only with 1 over x. In conclusion, I found out that according to equation number 1, tangents 45 over 2 degrees equals to 1 over x. And we have the trigonometric identity that says that tangents 2 theta equals to 2 tangents theta over 1 minus tangents square theta. Okay, repeat again. Tangents 2 theta equals to 2 tangents theta over 1 minus tangents square theta. In the next step, we define theta as 45 over 2 degrees. And therefore 2 theta will be equal to 45 degrees. In the next step, we substitute theta in this trigonometric identity by 45 over 2 degrees, and we substitute 2 theta by 45 degrees. So this will be equation number 2, and we will get that according to equation number 2, we have here in this trigonometric identity tangents 2 theta, and 2 theta according to our definition is 45 degrees. And it is equals to 2 times tangents theta. And theta, according to our definition, theta is 45 over 2 degrees divided by 1 minus tangent square theta. So it is tangent square theta, and theta, according to our definition, is 45 over 2 degrees. So I can find out that according to equation number 1, tangents 45 degrees equals to 2 times tangents 45 over 2 degrees over 1 minus tangent square of 45 over 2 degrees. Tangents 45 degrees is 1. We will define tangents 45 over 2 degrees as t. Now we can substitute tangents 45 over 2 degrees by t in this equation number 2. So we'll do it now, and we'll get that 1 equals to 2 times tangents 45 over 2 degrees is t, so it is 2t over 1 minus tangent square of 45 over 2 degrees. If tangent 45 over 2 degrees is t, it means that tangent square 45 over 2 degrees will be equal to 3 square. So in total, in the denominator we have 1 minus t square. 1 minus t square. So in conclusion, I found out that according to equation number 2, 1 equals to 2t over 1 minus t square. Here we will multiply this equation number 2 by 1 minus t square, and we get that according to equation number 2, 1 minus t square equals to 2t, Here we will add to this equation number 2t squared, and we get that according to equation number 2, 1 equals to 2t squared plus 2t. 1 equals to t squared plus 2t. Here we subtract 1 from this equation number 2, and we get that according to equation number 2, according to equation number 2, t squared plus 2t minus 1 equals to 0. Repeat again. We found out that according to equation number 2, t squared plus 2t minus 1 equals to 0. So actually, this is a quadratic equation. And the general formula for quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, a, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula. X equals to minus b plus minus the square root of b squared minus 4 times a times c over 2a. Okay. In our specific quadratic equation, t squared plus 2t minus 1 equals to 0, the variable that we are looking for is t. Therefore, x equals to t. The coefficient a equals to 1. The coefficient b equals to 2. And the coefficient c equals to minus 1. Now we can put the data inside the formula for x, and we find out the values of t because x equals to t. The variable that we are looking for in our specific quadratic equation is t. So we substitute x by t in this formula, and we get that, so x is t, and it is equals to minus b. b is 2, so minus b is minus 2, plus minus square root of b squared. b is 2, so b squared is 2 squared, that is 4. Minus 4 times a is 1, times c is minus 1, all divided by 2 times a, and a is 1, so it is 2 times 1. So in conclusion, we found out that t equals to minus 2 plus minus the square root of, so inside the root we have minus 4 times minus 1 is plus 4, and 4 plus 4 is 8. So in total inside the root we have 8. Only 8 is left, all divided by 2. So in conclusion, we found out that t equals to minus 2 plus minus square root of 8. 8 is 4 times 2, so we substitute 8 by 4 times 2 over 2. So t equals to minus 2 plus minus the square root of 4 is 2. Inside the root we left only with 2. So in total this expression equals to 2 times square root of 2 divided by 2. In conclusion, we found out that t equals to minus 2 plus minus 2 times square root of 2 over 2. So t equals to minus 2 over 2 is minus 1, plus minus 2 over 2 is 1, so in total this expression equals to the square root of 2. Okay. In conclusion, we found out that t equals to minus 1 plus minus square root of 2 plus minus square root of 2. So here we will have two solutions that are possible for t. The first solution for t is that t equals to minus 1 minus square root of 2, and the second solution that is possible for t is that t equals to minus 1 plus square root of 2. So according to the first solution, t equals to minus 1 minus square root of 2. Minus 1 minus square root of 2 is a negative number, therefore t is a negative number. But according to our definition, t equals to tangents 45 over 2 degrees, that is a positive number. From the other side we found out that t is a positive number. T cannot be simultaneously a negative number and a positive number, therefore we have a contradiction here. Therefore we cancel the solution and we left only with the second solution that is possible for t, that is t equals to minus 1 plus square root of 2. But according to our definition, t also equals to tangents 45 over 2 degrees. So t equals to tangents 45 over 2 degrees from one side, but from the other side, according to the second solution, t also equals to the square root of 2 minus 1. So actually, to enter the equation number 2, that states that tangents 45 over 2 degrees equals to the square root of 2 minus 1 from one side, but from the other side we have already found out that tangents 45 over 2 degrees equals to 1 over x. I'll show you that we already found it. Here. Here we have already found that according to equation number 1, tangents 45 over 2 degrees equals to 1 over x. So actually we have two different equations for the value of tangents 45 over 2 degrees. Therefore, we'll create equation number 3 that states that tangents 45 over 2 degrees according to equation number 1 must be equal to tangents 45 over 2 degrees according to equation number 2. Repeat again. We created equation number 3 that states the tangents 45 over 2 degrees according to equation number 1 must be equal to tangents 45 over 2 degrees according to equation number 2. Tangents 45 over 2 degrees according to equation number 1 is 1 over x, and it must be equal to tangents 45 over 2 degrees according to equation number 2. That is actually square root of 2 minus 1. So according to equation number 3, we actually found out that 1 over x equals to the square root of 2 minus 1. Here we multiply this equation number 3 by x, and finally we get that according to equation number 3, 1 equals to square root of 2 minus 1 times x. Here we divide this equation number 3 by square root of 2 minus 1, and we get that according to equation number 3, x equals to 1 over square root of 2 minus 1. in the next step, we will focus at this side of the equation, and we will multiply this side of equation number 3 by square root of 2 plus 1, and then we will divide it by square root of 2 plus 1. Square root of 2 plus 1 over square root of 2 plus 1 is 1. And it is allowable to multiply anything by 1. Therefore, this operation is allowable. And we get that according to equation number 3, x equals to 1 over square root of 2 minus 1. So here we will multiply this side of equation number 3 by square root of 2 plus 1, and then we will divide it by square root of 2 plus 1. So we actually change nothing, because we multiply it by 1. So in conclusion, we found out that according to equation number 3, x equals to, in the numerator we have square root of 2 plus 1 over square root of 2 minus 1 times square root of 2 plus 1. What is the value of this expression? Actually, according to the following trigonometric identity, that a minus b times a minus b times a plus b equals to a squared minus b squared. So according to this trigonometric identity, we will get that this expression equals to the square root of 2 squared, that is 2, minus the square root of 1 squared, that is 1. So in total, this expression equals to 2 minus 1, that is 1. So I found out actually that x equals to the square root of 2 plus 1 over 1. Square root of 2 plus 1 over 1 is square root of 2 plus 1. So in conclusion, we found out that x equals to either square root of 2 plus 1 units in its length, or in terms of numbers, x equals to 2.414 units. And that is the answer to the question. I repeat again, we actually found out that the length of this line segment BC that is equal to x, it is equal to either square root of 2 plus 1 units, or in terms of numbers, BC that is equal to x, it is equal to 2.414 units. Okay, so in the next step, I will summarize the lecture. So in this lecture, we found out the length of this line segment BC that is equal to x. According to what is given in the question, in the drawing we have 2 quarter circles. We know that side AB equals to 1 unit in its length. We also know that line segment QS equals to line segment SP. And again, our mission is to find out the length of this line segment BC that is equal to x. Okay. So this is a quarter circle, and therefore AB equals to PA. Those 2 line segments, they are both the radii of this quarter circle, therefore they are equal to each other. But AB equals to 1, therefore PA must be also equal to 1. Here PA also equals to 1, then join points P and B together by side line, and points Q and B together by a straight line. Likewise, in the big quarter circle, QC and CB, they are both the radii of this quarter circle, therefore they are equal to each other. But BC equals to x, according to what is given in the question, therefore QC must be also equal to x. Then I copied the right angle PAB in the new page. We implemented the Pythagoras theorem on this right angle, triangle PAB. This is the right angle PAB. This is the copy from the original drawing. Here by PT is equation for Pythagoras theorem. In this right angle PAB, PB square equals to PA square plus AB square. So PB square, that is the square of the hypotenuse, equals to PA square. PA is 1, therefore PA square is 1 square, that is 1, plus AB square. AB is 1, so AB square is 1 square, that is 1. So in total, PB square equals to 1 plus 1, that is 2. PB square equals to 2. We took out of this equation and finally found out that PB equals to the square root of 2 units. The graph of the hypotenuse PB is square root of 2 units. We can write here that PB equals to the square root of 2 units. Likewise, we copied the right triangle BQC in the new page and we implemented the Pythagoras theorem on this right triangle, triangle PQC. This is the right triangle PQC that I copied from the original drawing. Here by PT is a version for Pythagoras theorem. In this right triangle PQC, QB square equals to QC square plus BC square. So QB square, that is the square of the hypotenuse, equals to QC square. QC is x, therefore QC square is x square, plus BC square. BC is x, therefore BC square is x square. So in total, QB square equals to x square plus x square, that is 2x square. QB square equals to 2x square. We took out of this equation and finally found out that QB equals to the square root of 2 times x square. That is to say, QB equals to the square root of 2, and the square root of x squared is x. So in total, QB equals to the square root of 2 times x. So I can write down in the original drawing that the graph of the hypotenuse QB of the right angle QBC equals to the square root of 2 times x. Then we have here, we know that PA equals to AB in the right triangle PAB. And we have the rule that in front of equal sides in the triangle there are equal angles. So those two angles that are located in front of those two equal sides must be equal to each other. So if this angle is alpha, then this angle must be also equal to alpha because those two angles are equal to each other. And we also know that the sum of the angles in any triangle is equal to 180 degrees, and especially it is true in right triangle PAB. So which angles we have with the triangle PAB? We have alpha and alpha, that is 2 alpha plus 90 degrees. In total, the sum of the angles in the right triangle PAB must be equal to 180 degrees. I repeat again, the sum of the angles in the right triangle PAB is 2 alpha plus 90 degrees, and it must be equal to 180 degrees. Here we subtracted 90 degrees from this equation and finally found out that 2 alpha equals to 180 degrees minus 90 degrees is 90 degrees. We divided this equation by 2 and finally found out that alpha equals to 90 degrees over 2, that is 45 degrees. So this is angle alpha, and this is equal to 45 degrees, and this is angle alpha equals to 45 degrees in its sides. Likewise, if we repeat on the same process here, we arrive to the conclusion that those two angles are equal to each other. Each angle equals to 45 degrees in its size. Then I presented to you rule number 3 and we implemented rule number 3 in our drawing. According to rule number 3, the sum of the angles on one side of a straight line is equal to 180 degrees. In the drawing we have this straight line AB. If we focus on the upper side of the straight line AB at point Q, here the sum of the angles must be equal to 180 degrees according to this rule, rule number 3. So which angles we have at the upper side of AB at point Q? We have this angle alpha plus this angle beta. So alpha plus beta must be equal to 180 degrees according to this rule, rule number 3. We can actually implement rule number 3 in our drawing. Why? Because in our drawing, if you focus on the upper side of this straight line AC, at point B, here the sum of the angles must be equal to 180 degrees according to rule number 3. So in the next step I copied the straight line with point B in the new page and implemented rule number 3 in the straight line AC. So this is the straight line AC that I copied from the drawing. This is point B. The sum of the angles on the upper side of the straight line AB points. The sum of the angles on the sum of the angles on the upper side of this straight line AC at point B must be equal to 180 degrees according to rule number 3. So which angles we have at the upper side of AC at point B? We have this angle that is equal to 45 degrees plus this angle, the missing angle that we define as x, plus this angle that is 45 degrees. In total, the sum of those three angles must be equal to 180 degrees according to rule number 3. So in this side of the equation, we have 45 degrees plus 45 degrees is 90 degrees. So in total, we have in this side 90 degrees plus x, that equals to 180 degrees. We subtracted 90 degrees from this equation and finally found out that the missing angle x equals to 180 degrees minus 90 degrees, that is 90 degrees. So the missing angle is the right angle. So actually, this is the missing angle PBQ is equal to 90 degrees. Then I copied the right angle PBQ in a new page and we blocked this right angle PBQ by a circle. We have a rule that any triangle can be blocked by a circle and especially the right angle PBQ. So actually this is the right angle PBQ that I blocked by this circle. This angle equals to 90 degrees according to rule number 3. So in the drawing we have peripheral angle PBQ, that is the right angle, it is equal to 90 degrees in size, and we have a rule about a peripheral angle that is equal to 90 degrees. This is actually rule number 5. According to rule number 5, any peripheral angle that is equal to 90 degrees must rest on the diameter of the circle. So in the drawing we have a circle, inside this circle we have peripheral angle MAN. This peripheral angle MAN is a right angle, it is equal to 90 degrees. Therefore, according to this rule, rule number 5, this peripheral angle MAN rests on the diameter of the circle, or is subtended on the diameter of the circle. From the drawing itself, it is very easy to see that chord MN is the diameter of the circle, while because chord MN passes point O, that is the center of the circle, and we have that any chord that passes through the center of the circle must be the diameter of the circle. So in conclusion, you can say that because of the fact that peripheral angle MAN is a right angle, it subtends on the diameter of the circle. MN is the diameter of the circle. We can actually implement rule number 5 in our drawing. Why? Because in our drawing we have peripheral angle PBQ is equal to 90 degrees. Therefore, according to rule number 5, peripheral angle PBQ is subtended on the diameter of the circle. That is to say, PQ is the diameter of the circle. So if we define the radius of this circle as r, then the diameter PQ must be equal to 2r. Okay? The diameter PQ equals to 2r from one side, but from the other side, it is given us the equation that QS equals to SP. So if QS is x, then SP must be also equal to x because they are equal to each other. So QP in total will be equal to QS, that is x, plus SP, that is x. So QP in total equals to x plus x, that is 2x. QP or PQ equals to 2x. So from the other side, PQ equals to 2x. From one side it is equal to 2r, it is the diameter of this circle. From the other side, PQ equals to 2x. From those two equations, we derive that 2x equals to 2r. 2r equals to 2x. We divided this equation by 2 and finally found out that r equals to x. So you can write down that r equals to x and here also r equals to x. So here we have, we also found out that PS equals to r. So here PS equals to r and SP also equals to r. Here SP also equals to SQ. Here SQ also equals to r. Here SQ equals to r. That is to say, we have here two radii of this circle that touch each other at point S. And therefore point S must be the center of this circle. Here point S is the center of the circle. Then we join points S and B together by straight line. Point S is the center of the circle, point B is the point of the circle itself, therefore SB is the radius of the circle, that is R. So in conclusion found out that PS equals to SQ equals to SB. All those three line segments are the radii of this circle, therefore they are equal to each other. So here also we join points S and B together by straight line. SB is the radius of this circle. Again, SB equals to PS equals to SQ. They are all the radii of the previous circle. Therefore they are equal to each other. Then I copied this quarter circle to a new page, and then we completed this quarter circle to a circle. So actually this is the quarter circle that I copied from the original drawing. QS equals to SB equals to R. They are both the radii of the previous circle, therefore they are equal to each other. This angle equals to 90 degrees because this is a quarter circle. Then I completed this quarter circle to a circle. And then I presented to you a new rule, and we implemented the new rule in our drawing. Only to, the new rule is actually rule number 13. According to rule number 13, a central angle is twice as large as the peripheral angle subtended on the same arc. Here we have a circle. Inside this circle we have peripheral angle ACB. This peripheral angle ACB is subtended on arc AB and is equal to theta in its size. In addition, we have in this drawing the central angle AOB. This central angle AOB is subtended on the same arc, arc AB, and therefore according to this rule number 13, the central angle AOB will be twice as large as the peripheral angle ACB that is subtended on the same arc, arc AB. And because of the fact that peripheral angle ACB equals to theta, then peripheral angle AOB must be equal to theta according to this rule number 13. So the peripheral angle is twice as large as a central angle that is subtended on the same arc. That is rule number 13. You can actually implement rule number 13 in our drawing. Why? Because in our drawing we have the central angle QCB. This is the central angle QCB that is subtended on arc QB. And we also have peripheral angle BSQ. This is the peripheral angle BSQ that is subtended on the same arc QB. Therefore, the central angle QCB must be twice as large as the peripheral angle QSB that is subtended on the same arc, arc QB. Now we have to find out what is the size of the central angle QCB. We find out the size of this central angle QCB according to rule number 6. According to rule number 6, the sum of the angles around the point will always add up to 360 degrees. In the drawing we have this point A, and according to this rule number 6, the sum of the angles around point A must be equal to 360 degrees, or the sum of the angles around any point must be equal to 360 degrees, and especially this true about point A. In order to prove that this rule is true, I drew a straight line that passes through point A. Now we can implement here rule number 3. According to rule number 3, the sum of the angles on the upper side of this straight line point A equals to 180 degrees. According to the sum rule, the sum of the angles in the lower side of this straight line at point A also equals to 180 degrees. And therefore, in total, the sum of the angles in the upper side of this straight line at point A plus the sum of the angles in the lower side of this straight line at point A will be equal to 180 degrees plus 180 degrees, that is 360 degrees, exactly according to this rule number 6, that the sum of the angles around point A is equal to 360 degrees. Actually, you can implement rule number 6 in our drawing. Why? Because in our drawing we have, if we focus at point C, according to rule number 6, the sum of the angles around point C must be equal to 360 degrees. So which angles we have around point C? We have this angle that is equal to 90 degrees. It is a right angle. Plus the missing angle, in total it must be equal to 360 degrees. Therefore, the missing angle must be equal to 270 degrees. Why? Because 270 degrees plus 90 degrees is 360 degrees. That is the sum of the angles around point C according to rule number 6. So the missing angle here equals to 270 degrees. That is to say, the size of the center angle QCB is 270 degrees. And therefore, the size of the peripheral angle BSQ that is subtended on the same arc RQB must be equal to 270 degrees over 2, that is 135 degrees. So angle BSQ equals to 135 degrees in its size. And you also note, so if you focus on triangle BSQ, SQ equals to SB. And therefore triangle BSQ is an isosceles triangle. So QS equals to SB. And we have the rule that in front of equal sides in the triangle there are equal angles. So those two angles that are located in front of those two equal sides must be equal to each other. So if this angle is alpha, then the other angle must be also equal to alpha. And we also have the rule that the sum of the angles in any triangle is equal to 180 degrees. And especially it is true in triangle QSB. The sum of the angles in triangle QSB equals to 180 degrees. So which angles we have triangle QSB? We have this angle alpha plus this angle alpha plus 135 degrees must be equal to 180 degrees. So 2 alpha plus 135 degrees equals to 180 degrees. We subtracted 135 degrees from this equation. And finally we found out that 2 alpha equals to 180 degrees minus 135 degrees is 45 degrees. So 2 alpha equals to 45 degrees. We divided this equation by 2 and finally found out that alpha equals to 45 over 2 degrees. So this is angle alpha that is equals to 45 over 2 degrees, and this is also angle alpha that is equals to 45 over 2 degrees. Okay, then I copied the right triangle PBQ in a new page. We analyze this right triangle PBQ. Here, side PB of this right triangle PBQ is equals to square root of 2 units. Side BQ equals to square root to the square root of 2 times x units. PB equals to the square root of 2. PQ equals to the square root of 2 times x units. And this is angle SQB is equals to 45 over 2 degrees. This is angle alpha. So this angle is angle alpha that is 45 over 2 degrees. So in this right angle PBQ, tangents 45 over 2 degrees equals to PB over PQ. Again, tangents 45 over 2 degrees in this right angle PBQ equals to PB over PQ. PB is square root of 2. BQ is square root of 2 times x. We have square root of 2 in the numerator, square root of 2 in the denominator, so square root of 2 will get cancelled, and we left only with 1 over x. So in conclusion, we found out that according to equation number 1, tangents 45 over 2 degrees equals to 1 over x. Then we have the trigonometric identity that tangents 2 theta equals to 2 tangents theta over 1 minus tangents square theta. Then we defined theta is 45 over 2 degrees, and therefore 2 theta must be equal to 45 degrees. Then we substituted 2 theta in this trigonometric identity by 45 degrees, and we substituted theta by 45 over 2 degrees. In this trigonometric identity, I should have found out that tangents 2 theta is 45 degrees, and it is equals to 2 times tangent theta. It is actually tangent 45 over 2 degrees over 1 minus tangent square theta, and theta is 45 over 2 degrees. Then we defined tangent 45 over 2 degrees as t, and we substitute tangent 45 over 2 degrees in this equation number 2 by t. And found out that according to equation number 2, tangent 45 degrees is 1, and it is equals to tangent 2 times tangent 45 over 2 degrees, but tangent 45 over 2 degrees is t. So in total, in the numerator we have 2t over 1 minus tangent square of 45 over 2 degrees. If tangent 45 over 2 degrees is t, then tangent square of 45 over 2 degrees will be t square. So in total, in the denominator we have 1 minus t square. So in conclusion, found out that according to equation number 2, 1 equals to 2t over 1 minus t square. Here we multiply this equation number 2 by 1 minus t square, and found out that according to equation number 2, 1 minus t square equals to 2t. Then we added to this equation number 2 t square, and found out that according to equation number 2, 1 equals to t square plus 2t. We subtracted from this equation number 2, 1, and finally found out that according to equation number 2, t equals to t squared plus 2t minus 1 equals to 0. So this is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula, that x equals to minus b plus minus square root of b squared minus 4 times ac over 2a. In our specific quadratic equation, t squared plus 2t minus 1 equals to 0, the variable that we are looking for is t. So x equals to t, the coefficient a equals to 1, the coefficient b equals to 2, and the coefficient c equals to minus 1. So we put the data inside this formula for x and found out the value or the values of t, because x equals to t. So x equals to t, so therefore we substitute x by t, and it equals to minus b. b is 2, so minus b is minus 2, plus minus square root of b squared. b is 2, so b squared is 2 squared, that is 4. Minus 4 times a is 1, and c is minus 1. So in total, inside the root we have 4 minus 4 times 1 times minus 1 over 2a. So it is 2 times a is 1, so it is 2 times 1. So t equals to minus 2 plus minus square root. Inside the root we have minus 4 times minus 1 is plus 4. And 4 plus 4 is 8. So in total, inside the root we have 8. Divided by 2. So t equals to minus 2 plus minus. Inside the root we have 8. So we substitute 8 by 4 times 2. 8 is 4 times 2 divided by 2. And the square root of 4 is 2, so inside the root we left only with 2. In conclusion, found out that t equals to minus 2 plus minus 2 times square root of 2 over 2. Minus 2 over 2 is minus 1, plus minus 2 over 2 is 1, so in total this expression equals to the square root of 2. So in conclusion, found out that t equals to minus 1 plus minus square root of 2. So here we will have two solutions that are possible for t. The first solution for t is that t equals to minus 1 minus square root of 2. The second solution that is possible for t is that t equals to minus 1 plus square root of 2. According to the first solution for t equals to minus 1 minus square root of 2. Minus 1 minus square root of 2 is a negative number. But according to our definition, so t is a negative number, because t equals to minus 1 minus square root of 2. But according to our definition, t equals to tangent 45 over 2 degrees. That is a positive number. So t cannot be simultaneously equal to a negative number and a positive number. Therefore, we have a contradiction, and therefore this solution is the incorrect solution. We cancel this solution, and we're left with only the second solution that is possible for t, that t equals to minus 1 plus square root of 2. From one side, but from the other side, according to our definition, t equals to times 45 over 2 degrees. Here we created equation number 2. Coming to equation number 2, times 45 over 2 degrees equals to t from one side, but t from the other side also equals to square root of 2 minus 1. Therefore, here, this equation number 2 means that t equals to t, because t from one side it is times 45 over 2 degrees, and t is also square root of 2 minus 1. So t equals to t. This is according to equation number 2, or times 45 over 2 degrees equals to the square root of 2 minus 1. This is according to equation number 2. While according to equation number 1, we have already found out that times 45 over 2 degrees equals to 1 over x. Okay. We already found out here that tangents 45 over 2 degrees, according to this equation number 1, equals to 1 over x. So we have two different equations for the value of times 45 over 2 degrees. Therefore, we created equation number 3. According to equation number 3, tangents 45 over 2 degrees according to equation number 1 must be equal to tangents 45 over 2 degrees according to equation number 2. So tangents 45 over 2 degrees according to equation number 1 is 1 over x. It must be equal to tangents 45 over 2 degrees according to equation number 2, that is square root of 2 minus 1. So in conclusion, we found out that 1 over x equals to the square root of 2 minus 1. We multiply this equation number 3 by x, and finally we found out that 1 equals to the square root of 2 minus 1 times x. Here we divided this equation number 3 by square root of 2 minus 1, and finally we found out that x equals to 1 over square root of 2 minus 1. So here we multiplied this side of the equation by square root of 2 plus 1, and then we divide it by square root of 2 plus 1. Square root of 2 plus 1 over square root of 2 plus 1 is 1, and it is allowable to multiply anything by 1. So here x equals to 1 over square root of 2 minus 1. We multiply this side of the equation by square root of 2 plus 1, and then we divide it by square root of 2 plus 1. Therefore we change nothing. In conclusion, we found out that x equals to the square root of 2. In the numerator we have square root of 2 plus 1. In the denominator we have this expression. This expression square root of 2 minus 1 times square root of 2 plus 1. According to the algebraic identity, that a minus b times a plus b equals to a squared minus b squared. So the value of this expression according to this trigonometric identity will be equal to the square root of 2 squared, that is 2, minus square root of 1 squared, that is 1. So this expression in total, according to this trigonometric identity, will be equal to 2 minus 1, that is 1. So x equals to the square root of 2 plus 1 over 2 minus 1 is 1. So square root of 2 plus 1 over 1 is square root of 2 plus 1. In conclusion, we found out that x equals to either square root of 2 plus 1 units in itself, or in terms of numbers, x equals to 2.414 units. Repeat again, we actually found out that the length of this line segment BC is equal to x. It is equal to either square root of 2 plus 1 units, or in terms of numbers, BC is equal to x, equals to 2.414 units. Okay, thank you very much.